This is a little puzzle ball. Inside this ball, you can hear it there, I made two. Inside these balls, each of them is a 20p coin. And it's a little idea that a mate of mine got. We saw something on the Antiques Roadshow where somebody had one of these puzzle balls. He took a couple of photographs and we've since made them. That's Pete Townsend, who's the guy that gave me the ideas. And what you do with this little puzzle ball, you create these rings around the ball. And of course then one of these rings you press out to expose a little box inside. That's quite a tight press fit. There you go. You press it out. Out slides the little box. And there is a little box, a 20p coin inside. It fits in there, nice and snug, and that fits in your box. It's a little bit of fun, not particularly necessary to keep a 20p inside a wooden ball, but particularly necessary to try and make one. So I'll take you through the various steps. I have made two. Each one has had room for improvement. Even this one here, there's room for improvement, and hopefully the learnings of making these two, you'll see come through in the one that I'm going to demonstrate for you now. So enjoy the video, and we're going to kick off by getting a bit of timber, exactly 70 millimeters by 70 by 70. So we want a cube of timber, as square and as accurately as you can get it, you must make it. And with that, we'll then bring it to the lathe and get exact centers on each of the faces. So the next thing for me to do is to go and cut up a cube 70 by 70 by 70. So I have a lovely piece of Iroko here, or African teak, and what I've done on the planer, I've made two faces perpendicular to each other, two reference faces. And now what I'm going to do is I'm going to come using the table saw, making sure that the reference faces are always on the bed and against the fence. I'm going to rip this into a length 70 millimeters wide. I've set the fence at 70 millimeters. I've locked it in place. I can now raise the blade. I always leave my blade down. Raise the blade. I'm in fact going to do it in one pass. The blade teeth just protruding at the top. I can do it in a pass. Speed is correctly set. I'm now going to switch on the vacuum cleaner and make two cuts to get this in its square form. So there we've got our cube, and now I'm going to take it to the miter saw and cut a 70 millimeter block off that. Just coming over to the miter saw, just checking the dimension. I see I actually cut this a little bit smaller. It's about 69 millimeters. So what I'm going to do, I'm going to put the vernier on the 69 millimeters. I now need to get a nice square face, which I'll cut here. Then I'll come and I'll mark the same distance, and I'll show you a trick with marking, and then cut the final piece. So the first thing is to cut it at 90 degrees. I've checked that my miter saw is correctly located. There's 0 degrees on the fence. The vacuum cleaner pipe is on. The pipe is on for the vacuum at the back. I'm all ready to go. Put my safety goggles on, and I'll make the facing cut. Now when I'm doing this as well, I'm looking at this bit of timber. This side of the timber is a bit discolored, and I think it was the end of a plank that had been after when it was seasoning, and it's picked up oils and some other miscellaneous things from the atmosphere. So you don't want to be using that piece. I'll be working on this end here, so I'm going to face it off 70 mils, cut off the next one. Now I've measured this dimension of the timber over there. I need to make a line on here to cut to the saw. Now You could try and put the calipers like that, or you could try and maybe use the tailstock, but there's a very nice feature on the back of the vernier over here, a little lip collar. You put that up against the face, hold it square on the face, make a mark with your pencil, and I want to cut on that side of the line, and I can come with a nice engineering square, put it on that line, and that's where I'm after. And I can check again. Perfect. Bringing it back to the saw. So there I've got my. So there I've got a cube as close as I can get to being exactly cubic, and I'm going to take that to the lathe now. So the next thing we need to do is to mark the center of each of these 6 faces of the cube. Now what I'm going to do here is use my 100mm jaws in my chuck. I'm going to mount this bit of timber in that. It will center itself, obviously, as the jaws close. As the jaws then close, I just check that it is sitting nice and central. So now I know that it is centrally in there. I come along with this tool, which is actually a center normally used in metalwork turning, but you can buy these off the internet, fairly easily accessible. I've got a dedicated chuck for this. It's something I bought second hand. I'm going to fit that into my tailstock, and I'm going to come up and make a very small mark in each of these end faces, and that mark you'll see how we use that later on. Perhaps thinking, why don't you just mark it with a corner to corner and use a center punch? And I find when I do that with a center punch, because of the end grain, especially on the end grain, sometimes the grain makes the punch walk a little bit to the side, so it doesn't actually make exact centers. With this very chubby little bit, there's no way that that's going to get deviated by the grain, and it'll definitely cut where I want it to cut. One more to go, facing there. So there we've got our 6 faces marked off. Now what I'm going to do is create the cavity within the box, within the box that will take the inside box. So I'm going to come along and bore out with a 35mm 4s and a bit to the right depth, and then go right through with a 16mm drill out the other end to create the interior shape within the box. Let me show you here. I can get this out again. So we're going to bore in this distance there, and then go right through with the smaller 16mm drill. So we need to drill this 35mm hole. It's going to be about 35mm deep. It's quite convenient. In this face over there, I'm working with the grain, so 90 or running with the grain. As I work through my jobs, I'll show you some of the things I do with my 3D printer. This is just a storage system that I use for my drill bits. I've created these boxes with all of my drill bits of the various sizes. It's a nice box. You can easily reference the one you want. I've done this with all of my drills, and they're all interlocking and store a lot of drills nice and accurately in my cabinet. So I'm going to go ahead and drill this hole. So I like to use the vacuum cleaner, the extractor, when I'm drilling. You get very fine dust. You can actually see some of it here and there, and it just takes it out of the way. 35 millimeters deep. So I marked it on the bit. And whenever you're drilling a hole with sort of shoulders in or different diameters, you need to start with the biggest drill size first, because this will pick up it'll create a center. If this is drilling to that center, when you come with the next smaller drill size, it'll pick up on that center. Make sure that you keep it concentric. So if you had to drill a small hole first, you wouldn't have the center point to pick up the bigger hole after that. So that's why you always start with the biggest and then move to the smaller one after that. Now you would have seen that I didn't reverse the drill in and out, because I noticed the chips were feeding down the flutes, being ejected out the back of the drill. So it was cleaning itself, but if you see that your drill is not cleaning itself, you need to remove it, clean it out and go back in. It will avoid you getting any heat distortion or heat problems in the hole. And anyway, so there we've got the hole done. Next thing, I'm going to give it a quick sand, clean it up, and put some sanding sealer on before I move on. So we're going to do some finish sanding inside here. I've got a fairly simple block of wood with a few grooves cut in it, and I've got my abrasive paper in here, 80, 120, 180, 240, 320 and 400. There's 600 and fine if I need it. But what I'm going to start with here is come in with a bit of 120. I want to be sure that I don't create a sort of outward tape. I want the hole to continue to be parallel, so I need to make sure that I move the sandpaper up and down evenly inside this cavity. So I'm going to put the extraction on and do some sanding. So I'm using a sanding sealer, chestnut product sanding sealer. I keep it in a tin. It was a vitamin jar of some sort. The brush, it's mounted with a electrical grommet into the lid, so the brush fits nicely. I can apply it inside the hole. The cellular sanding sealer hardens quite quickly, so you can apply it liberally. What it does, it actually goes and binds the fibers together. Gives a good surface for sanding and finishing. So next up, I need to make that little box I spoke about. This was the piece of waste timber that you saw earlier on. I've just squared it off in the miter saw, so that's nice and flat. And I'm going to mount this in these chucks. Now, there are many different ways that you can mount timber in a chuck. You could put a collar, make a tenon, turn between centers and make a tenon and fit it to a tenon, which is a very secure way, which is normally what I would do. But I had the jaws in the chuck on the lathe, so that's what I'm going to use. I make sure it's seated nicely against the face of the chuck, tighten it up, and I'm ready to turn. Wherever you can, you should use your tailstock to center. So that I'm going to bring up. So now I've got a nice secure bit of timber, and I'm going to start shaping this guy here. So what I'm going to do is I'm going to first bring it down to around to about this dimension over here, so just a bit of stock material round, and then I'm going to come and shape this to that dimension, and then come out the shoulder and do the barrel. And I've mounted it on a chuck like this so that I can remove the tailstock and just check for fit as and when I need to. So that's what I'm going to be doing next. So on with the tool rest, get the height of it right, just below the center line, because my chisel is going to bring it up to the center line. You cut generally at the center line. Not on all chisels, not on the skew chisel, but certainly on roughing gouges. Tool rest in place. It's free from the timber, that's locked in place, that is locked in place. So everything's locked in place, all ready to go. Start at the slowest speed, increase the speed to something that you're comfortable with. And I'm going to come in with my roughing gouge. Now what I've done with all of my gouges, I've made little protective sleeves on the ends, held on with magnets, all 3D printed. Main reason is when I do go traveling with these things in a bag that it doesn't dig a hole through the corner of my luggage. But it also does keep the edge protected. So this has been sharpened, it's ready to go. When I bring it up to the piece of timber, I'm going to make sure that it's first firmly on the rest with my right hand going down. I'm going to make sure it's rubbing on the bevel, and then I'll lift it up and get it engaging with the cutting edge, and then move to the back and forwards, slowly taking timber off. I'm just going to start getting this round. On the rest, hand down, lift it up.
I'm going to do is I'm going to cut a couple of grooves at that dimension and then machine it out to that. But I'm going to put my mask on so you won't get any more vocals from me while I do the next thing, but and I'll speed it up as well if you don't bore yourself to death.
So a couple of words to what I've just done. I mean, with this vernier, I've got a video which shows you how to, some of the benefits of a vernier, but I've taken this corner off the vernier, so that means I can bring it up and use it as a caliper. So the vernier, which doesn't only measure diameter, I actually don't particularly even need to know what it is. It's locked, it's like a caliper. It's got those little corners rounded off, but where you're measuring in the center here, you can ride onto the center, and as it slides on, you know you're at your diameter. You also might have seen that when I come in with my chisel, you create a bit of space, so you do two cuts, sort of with half a millimeter or millimeter to the left, just to make sure that you've got enough space at the edge, you've got clearance between this edge and that face to reduce the friction and the heat buildup. As you get down to narrow chisels, it becomes more and more significant. So now what I'm going to do is I'm going to remove this material between here, and then I will have the shaft still oversized, and then I'll come and do the proper sizing. So mask back on, and let's finish off this job. So we're back to the lathe. You can see those flat areas where I've got my target dimension. Just want to check. It's always easy to check it now that I'm getting close to the right dimension. You can see it just starting to catch there. So if I flatten this down to that dimension and then work from there, I should be in the right ballpark. This is Richard Findley, who's an incredible production turner, real craftsman. He has this Richard Findley 3/8 signature chisel, which is basically a 3/8 of an inch parting chisel, or flat square chisel, and it's got rounds on the corners, and you can use it as a parting tool or as a skew chisel, which I am practicing to use, and if you really want to know how to use it, you should watch his channel. Tail stops engaged, and I'm going to come across on this, using this edge of the tip, moving that way, a very light planing cut. It's very fine shavings, but they are actual shavings. It's not sawdust. Just trying to maintain the surface and have a nice smooth cut. Just check see everything diameter wise. It's kind of tight. I'm going to leave it at that dimension for now because the next thing I'm going to do is bring this diameter down to 16 millimeters for that other hole. So I'm going to come in with my caliper, loosen it off with my vernier, check the hole diameter, slightly bigger, and I need to go in now to about over there. These dimensions aren't critical in terms of length, as long as the box fits nicely in the hole. So I'm going to mark a line there, and this is the area that I need to now bring down to 16 millimeters. Now we need to just check. It really is a case of slowly catch the monkey. Here's our block of wood. Okay, we're close, but we're not where we want to be. It's a bit tight, and not very tight. But it's the right order, the right sort of size. I'm going to take it down to that dimension, right to the end of the collar. The shoulder over there, so back in there. Okay. Okay, so just going around that way. We now need to shape this and get this down to size. We know that it fits in there, and we now just need to size this. So we're a little bit bigger than we would need to be, but I'm going to see whether we can come down to size with a bit of sandpaper.
Cautious, but why not?
Fits nice and snugly. I need just to give myself a little bit more room because I've got to part this off. So I've got to have the width of the parting chisel. And then I'm going to put a little collar on for the lid. So I need another 6-7 millimeters. And then we've got the piece that's going to go inside the lid. Now, when you're making a box, there's always a question, do you make the lid first or do you make the base first? And from a bit of experience, you make the base first. You cut this hole, this dimension here, and then you get the lid to fit to that. It's easier to control cutting this dimension than changing the inside diameter here. So I'm going to drill this out. Looks fine. It's cutting nicely. can see the shavings are coming out nicely. It tells you the chisel's nice and sharp. It's cleaning it away. There's not too much heat build-up. Those are good shavings. And if you start finding that if you get too much sawdust, it's time to sharpen your Forstner bits. Buy a small set of chisels or files and just work the edges nice and straight. Okay, here we go. Nice shavings, I mean, great stuff. Take it out the way, lay it off. Oh, it's hot. So, Forstner bit, I like to clean my bits before I stick them back in my nice little holders. Now I'm just going to quickly clean this edge up inside. We'll clean up the inside with a bit of sandpaper, but being very careful not to bring the sides in. I want to make sure that they're parallel. So very lightly with 240 grit. To the outside, just to the face a bit of a clean, and then come inside. Okay. Got to get it all done, set down. Then I normally do this. I've got a little junior hacksaw, pop it in there, saw it off. And why I do that is you don't, if you tear out some of this end grain, which you can do when you come in with a potting chisel, and you're trying to finish off something and have a good finish, there's nothing worse than having the little torn out grain because it's gone. If you use the potting chisel, a junior hacksaw, then you can shape it, finish it, do whatever you need to do without tearing off the grain. So there's the inside of our box. I can now take this out of the chuck and we can move on to the next step. So we need to find a way to hold this to machine that end in. What I'm going to do is use a jam chuck. So this is a piece of timber that I'd used before for jobs number 1 and 2. And basically I've mounted this in the lathe and drilled a 60mm hole that fits in quite snugly. In fact, it's a little bit loose because this has been sanded. But I'm going to now mount it in here. So it's in the lathe. It's mounted in there. Because it's a bit of a loose fit, I'm going to put a bit of masking tape around the shaft. So just one turn of masking tape. You could also use hot melt glue. And when you bring the masking tape down to the end, make sure that it doesn't overlap too much, otherwise you will not be round. There we go. Roll it shorter than longer. And that is in nice and firmly. The center is going to hold it in. And now I can come and machine a little lip to fit the box that we made earlier. The diameter that I'm after, which is the same as inside diameter over there. So I could either have measured it there, or I can check that it is in fact consistent with what I'm after here. Okay, that is quite tight, but now what I'm going to do is I'm going to come to the final size with some. I'm going to go with 180, quite aggressive, but there we go. And it's got a pop. Known in our club as the Roger pop. That's a nice tight fit. There we've got the basis of our box. So we have the box inside what's going to become our sphere. It fits snugly. It protrudes a bit. I'm going to come with a bandsaw and take those protrusions off and come back to the chuck. So I've cut off the excess with the bandsaw. Now I'm going to come back to the chuck and create those centers. Make sure it seats well. And I'm going to come in and just make a mark the center. Same on the other side. Okay, so we now have our box, our cube. All the sides are the same size, the centers are in the center, mark them all, and we are now going to turn this into a sphere. These centers will be relevant, you'll see where later. So I'm going to take the chuck off, I'm going to put in a drive center, and then mount this and make a sphere. So this is the drive center. It's a spring-loaded drive center. So the central point is spring-loaded, so it doesn't indent too far into the wood. But these little teeth then grip the wood and turn the wood accordingly. Now, a little hack with these: if you find that it's starting to slip, that your teeth aren't sharp enough, you can sharpen them with a file. But just get a pair of pliers, grab this point and pull it out. It's just a press fit. Gets it out the way, and then you can come in with a file and clean up your teeth nicely and get nice sharp teeth. And then also when you mount it into the headstock, make sure that there's no dust in the headstock, because you need this Morse taper 1 or in Morse taper 2 if you've got a bigger lathe to have a nice snug fit in to the drive. So we have the drive center, the live center. Marking or mounting it, between centers with the grain running in this direction on those center points that we've made. And getting it to dry out, you can see it's spinning, and now it takes, the teeth take. We're going to turn this into a sphere. Now, this is a sphere between centers. There are many different ways to do a sphere. This is probably my preferred way. It's a technique that I got out of a book. This is a book that was gifted to me by friend Andre Oosthuizen, with Tuning Methods by Mike Darlow. Page 85 has a technique to turn a sphere. The diagram shows how you create target points, and I'll take you through that now. So I'm going to turn this into a cylinder. Get a tool rest, get it to the right height, make sure it clears, but it's close enough. Tighten it in, make sure everything's clamped. Finger. So we now have a piece of wood that is as round as it's long, because this was, remember, this was a cylinder, a cube. So it's as round there as it is long here. And now what I've done with my little 3D printer, I've got a little template that I made where I've got one mark for the center, one mark over there, one mark there, which are according to the, so that's the center line, which it runs exactly on the center. That's perfect. And then this is 0.414 times the diameter, is that dimension there. So we marked the center line here. We marked 2 points on either side of that, which are 0.414 total distance times the diameter apart, or half of that from the center of each. Equidistant, this dimension down there, we've created 2 more points. And now the job is to remove the material on that cone over there. I'm using a 3/8 inch bowl gouge, and I'm going to come in with the bevel in the direction that I'm wanting to cut, and I'm going to have it fairly closed as I start the cut. And once I've got the cut, I'm going to slowly rotate it and present more of the cutting edge and cut a 45-degree bevel. You can see the bevel is always parallel to the direction that I'm cutting. If it's not, if it's like that, it will run up the wood and disturb the wood. So you must really just practice that. Rotate your swivel, and you get a lovely, I mean, if you look at the finish of that cut, you don't really get it much better than that. Nice and shiny. Anyway, we need to keep on doing this. And I think it's good practice to start with the flow. as you're working down there, you can check that the distance between your edge and that line is the same as the distance between the end of that edge there and the line that you've marked in the face. It means you are coming in at 90 degrees, at 45 degrees. Okay, so close the bevel, pick it up, rotate it. I'm just going to do a straight. So I've closing the bevel. Using this bottom edge, get it really nice and closed, and it's a scraping cut, a full cut. Okay, and now we do the same on the other side. So bevel parallel to the direction you want to go. The next thing we need to do is to find the center point of this. Yep, that's the same. 15 over there. And mark those points. Just going to give it a bit of angle. And same on that side. You're going to remove the material all along here. You're going to keep these lines absolutely intact. You'll just work our way up to those lines and up to this line. So the material that's here we're going to remove, and the material that's there, and then the material that's between that center point and that line, this material here, to shape the sphere. Shaping of the sphere, I've got a little 3D printed template. And you can make one yourself as well. So it's just a cut out 69mm sphere, and I'm going to work myself and work the shape to that shape. So put that aside, coming in with my bowl gouge again, and I'm going to take those high points off. Try and get around the corner as best you can. Again, the target is now the top, the South Pole in this case. We're getting end range. So we've used some sandpaper to get to the shape. We've used the jig just to check that we were coming right. This side.